Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss Chemistry Chapter Solution Part 1 for the students of class 12 and for the students who are appearing for IIT, NEET and other entrance examinations. Before we begin, we have a small request for you. Please subscribe, like and share our YouTube channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. So first thing which comes to our mind is what is solution. So solution, to explain solution, first let us take an example. Take a glass of water and put some salt into it. Stir the water. After some time, you can see there is no salt remaining which is visible. All the salt particles are dissolved into the water. So here this salt water is called solution, and the salt is called solute, and water, pure water before mixing up salt was solvent. Now let us see the definition. So solution, when two or more than two substances mix and form a uniform or homogeneous mixture, such a mixture is called solution. So here the salt water is called a solution. So let us see what is solute and solvents definition. The proportion of components which is less in solution is called solute. In our example, salt's proportion was less than that of water's proportion. So the salt was a solute, and the proportion of component which is more in solution is called solvent. So water proportion was more and it was known as solvent. There can be one solvent and more than one solute in a solution. So in our experiment we can make sugar also in the salt water. So in that case sugar and salt both are the solute. So here point to be remembered that solute can be more than one, but solvent will be one. Binary solution. So our example which we have taken for salt water solution was a binary solution. The solution, now come to the definition. The solution having one solute and one solvent is called binary solution. So in our experiment there was one solute which was salt and one solvent which was water. So our solution was an example of binary solution. Now one sentence where fill in the blanks can come or any objective can come. So I have marked it. So in a homogeneous mixture, the different component cannot be separated by physical method like filtration, sedimentation, boiling or centrifugation. So this point to be noted that Solutions cannot be separated by any of the physical methods. One more important point. In a homogeneous mixture, the diameter of a molecule particle is 10 to the power minus 9 meter. Types of solution. Solution can be found in three states. A. Solid solution. B. Liquid solution. And C. Gaseous solution. So let us see solid solution. In solid solution, always remember the solvent will be in the same state as the state of the solution. So here in solid solution, the state of the solution is solid, therefore solvent will be solid in all the cases. So in the first type of solid solution can be solute is solid, solvent is also solid, and solution is a solid solution. Example of this type of solution is brass, alloy formed from copper and zinc. Second, second type of solid solution can be solute is in liquid, solvent is in solid, and it gives solid solution. Example, zinc amalgam. Zinc dissolved in mercury. And third type of solid solution can be solute is in gas, solvent is in solute, and which gives solid solution. An example can be absorption of hydrogen gas in PD. Now, liquid solution. Liquid solution can also be of three types, where liquid solutions state is liquid, so the solvent in all the three types will be liquid. So first type of liquid solution can be solute is in solid, solvent is in liquid, which gives liquid solution. Example, homogeneous mixture of sugar and water. Second, solute is in liquid, solvent is in liquid, gives liquid solution. Example, homogeneous mixture of water and ethanol. And third type of liquid solution can contain solute. Solute is in gas, solvent is in liquid, which gives liquid solution. Example, homogeneous mixture of carbon dioxide and water. Gaseous solution. So gaseous solution can also be of three types. Here the physical state of gaseous solution is gas. Therefore, solvent in all the three types will be gas. First type of gaseous solution may contain solute is in solid state, solvent is in gas, and which gives gaseous solution. Example, homogeneous mixture of camphor in N2 gas. Second, solute is in liquid state, solvent is in gaseous state, which gives gaseous solution. Example, air containing moisture. And third type can be of solute is in gas plus solvent is also in gas, which gives gaseous solution. Example, mixture of H2 hydrogen and O2 oxygen gas. Various conditions for forming a solution. So if a number of hydroxyl group in an organic compound is more in a solute, it is more soluble in water. That is, more the number of hydroxyl group, more is the solubility. For example, glycerol, if you count, if you see the structure of glycerol, it has 3 hydroxyl group in its molecule. So it is more soluble in water than ethanol. If you see the structure of ethanol, it contains only one hydroxyl group. So glycerol is more soluble in water than ethanol. Second point is most of the polar solute dissolves in polar solvent. So what is polar solute? Polar solute means any of the ionic compounds which can be separated in different charges. For example, HCl, in HCl it can be separated as H plus and Cl minus. So it is a polar substance. So we mean to say that most of the polar solute, so if HCl is a polar solute and water is a solvent, if we take water as a solvent, then water as a solvent, then both are polar here, so HCl is soluble in water. It is more likely that HCl is soluble in water because both are polar. Most of the non-polar solute dissolves in non-polar solvent. So it is just opposite of point 2. So here we want to say that non-polar solutes dissolves in non-polar solvent. For example, naphthalene and benzene are non-polar solvent. So they cannot be divided as a partial charges. Both are non-polar solute. Both are non-polar substance. So if we take naphthalene as a solute and benzene as a solvent, then naphthalene is more readily to dissolve in benzene because both are non-polar. Most of the ionic solute, point number 4, most of the ionic solutes are soluble in water because they are ionic even in solid state. So let us take an example of NaCl in water. So NaCl and water both are NaCl is an ionic compound. So Na contains plus sign and Cl contains minus sign, and water can also be written as H plus and OH minus. So it has been seen that most of the ionic compound are more soluble in water than any other solvent. Aqueous and non-aqueous solution. Aqueous means water. So if the water is the solvent in the solution is known as aqueous solution. Opposite to that, if water is not the solvent, the solution is known as non-aqueous solution. In non-aqueous solution, generally benzene, ether, carbon tetrachloride, etc. are used as non-aqueous solvent. Now let us see an example. So let us see an objective question which is important for NEET and other any exam where objective questions are asked. Example: choose solvent and solute in the following cases. First, brine solution. Second, crystalline copper sulphate. Third, aqueous solution of copper sulphate. Fourth, equimolecular solution of water and ethanol. So, first answer, brine solution is the aqueous solution of NaCl. Here, water is the solvent with greater percentage and NaCl is the solute. Solution to the next question. Crystalline copper sulphate solution is CuSO4.5H2O. So here CuSO4 is solvent, as physical state of the solution is same as of solvent. In an aqueous solution, third one, in an aqueous solution, solvent is always water. Fourth one, 1 mole of ethanol is equal to 46 gram. 1 mole of water is 18 gram. Therefore, solvent is ethanol and solute is water. Units of concentration. So, till now we have studied about solution, solute, solvent. Now, what is the way to measure this concentration of solute into a solvent, or the proportion of solute in a solution, or proportion of solvent in a solution? So there are few. So first let us understand what is unit of concentration. The quantitative proportion of solute and solvent are different in different solution. The amount of solute in a unit volume of solution or unit weight of solvent is called concentration of solution. So there are different ways to express the concentration of solution. First is formality, second is volume percentage, third is mass by volume percentage, percentage W by V, and fourth is parts per million, ppm. So let us see about formality. In 1 gram, formula mass of a solute is dissolved in 1 liter solution. It is called formal solution. And this type of concentration is called formality. It is indicated by symbol F. So again, let us see, if 1 gram formula mass of solute. So here solute is 1 gram formula mass of the substance, 1 gram mass of the substance of its formula mass. So first we'll calculate the formula mass from its molecular formula to find out 1 gram molecular mass, formula mass. And solvent is and it is dissolved in 1 liter of solution. So it is dissolved in 1 liter of solution. It is called formal solution, and this type of concentration is called formality. So this is known as formality and it is denoted by F. So according to the definition, formality F is equal to, we can write 1000 multiply by mass of the solute in gram upon formula mass of the solute multiply by volume of solution in ml. So let us see how we get this formula. So it is very simple. So according to the definition, we can write gram formula mass of the solute as this one, this whole. So mass of the solute in gram upon formula mass of the solute and volume of the solution in liter. So as per the definition, we can write this. So again, we can write mass of the solute in gram upon formula mass of solute multiply by volume of solution. If it is given in ml, then we have to convert into liter. To convert ml into liter, we have to divide by 1000. So this will go up. So mass, final formula of F will be mass of the solute multiply by 1000 upon formula mass of solute multiply by volume of solution in ml. Now let us see an example. Numerical. Calculate the formality of a solution in which 948 gram of potash alum is dissolved in 5 liter solution. So formula mass of potash alum is 474 gram. You have to calculate it out from the molecular formula of potash alum. So formality of potash alum, F is equal to 100. Just put the formula 1000 in multiply by mass of the solute in gram upon formula mass of the solute multiply by volume of the solution in ml. So in our case, we'll just put 1000 multiply by 948, since 948 is the molecular formula mass of potash alum. 474 is given as 948 is given that it is given in the question that it is the gram uh, potash alum, gram of potash alum, 948 gram of potash alum is dissolved in 5 liter solution. So we have put mass of solute in gram as 948. Again, formula mass of potash alum is 474. So we have written instead of formula mass of solute as 474. Multiply by volume of solution in ml is 5000. which is equal to zero point 0.4. Upon solving, we get 0.4 F formality. So the formality of potassium solution will be 0.4 F. Volume percentage. So the volume of a solute in ml dissolved in 100 ml of solution is expressed as volume percentage V upon V. Such a solution is called percentage proportion with reference to the volume of solute. Therefore, percentage V upon V is equal to 100 multiplied by volume of solute in ml upon volume of solution in ml. Now let us see a solved example, solved numerical of this type. Calculate the volume percentage of a solution in which 200 ml ethanol is dissolved in 2 liter of aqua solution. To this problem is, so here what are given? It is given that 200 ml of ethanol is dissolved in 2 liter of aqua solution. So volume of ethanol is given as 200 ml. Volume of the solution is given as 2 liter. So just we'll put these values into the formula of volume percentage. So percentage V by V is equal to 100 multiplied by volume of ethanol in ml upon volume of solution in ml. So 100 multiplied by 200 upon 2000, which is 10%. So concentration of aqueous ethanol solution is 10% V upon V. Let us see another example. How many ml of kerosene is required to prepare 5 liter of 15% V by V kerosene in petrol solution? So here things are given is volume of solution, that is 5 liter. Percentage V by V is given as 15%. We need to find volume of kerosene. So 5 liter solution is equal to 5000 ml of solution. Now we'll put the formula for percentage V by V is equal to 100 multiplied by volume of kerosene in ml upon volume of solution in ml. That is, percentage V by V can be written as 15 is equal to 100 multiplied by volume of kerosene upon 5000. Now after putting up all the values which are given, we can find out the volume of kerosene by cross multiplication. We can write that 15 multiplied by 5000 upon 100 is equal to 750 ml. Therefore, 750 ml of kerosene will be required to prepare 15% V by V 5 liter solution. So mass by volume. Mass by volume percentage W by V. The mass of solute dissolved in 100 ml of solution is called mass by volume percentage, that is percentage W by V. Such a solution is called percentage weight proportion with reference to the mass of solute. We can write percentage W by V as 100 multiplied by mass of solute in gram upon volume of solution in ml. To get a clear understanding, let us solve one example of this concept. How many grams of sugar will be required to prepare 5% W by V 2 liter aqua solution? So 2 liter means 2000 ml solution. Now percentage W by V formula is 100 into weight of the sugar in gram and volume of the solution. So here instead of solute we have written sugar because sugar is the solute in our case. So putting the values which are given, percentage W by V is given as 5% and volume of the solution is given as 2 liter, that is 2000 ml. So 5% is equal to 100 multiplied by weight of the sugar upon 2000. We need to find the weight of the sugar. So by cross multiplying we can find the weight of sugar is equal to 5 into 2000 upon 100, that is 100 gram. Therefore, the answer is 100 gram of sugar will be required to prepare 5% weight by volume 2 liter solution. Let us see one more example to get more clear concepts. So calculate a percentage W by V containing 200 gram urea dissolved in 5 liter. So it is given that 5 liter solution, which means 5 liter solution is equal to 5000 ml solution. So just writing the formula for percentage W by V is equal to 100 multiplied by weight of urea in gram upon volume of solution in ml, that is, and putting the values we get 100 into 200 upon 5000 is equal to 4%. So the concentration of urea solution will be 4% mass by volume, that is W by V. So now we'll discuss fourth type of concentration, that is parts per million, ppm. Sometimes the amount of solute in solution is very less, and so the concentration is expressed as parts per million, ppm. For example, pollutant in pollution of air. So for example, pollutant in polluted air. So pollutant can be carbon monoxide, but its percentage is very less. It may be 0.004, something like that. So these type of measures, concentration measures, which are very small, are expressed as parts per million. Again, the amount of oxygen dissolved in seawater, or we can see pollutant in pollutions of air, so a comma, so etc. are expressed by this unit. Parts per million can be expressed by different ways as parts per million by mass to mass, parts per million by mass to volume, and parts per million by volume to volume. Parts per million by mass to volume. So is mostly used, and others are other. It is mostly used. Parts per million, mass to volume. The amount of solute in milligram dissolved in 1 liter of solution is called parts by per million by mass to volume. So parts per million by mass to volume can be written as, according to the definition, can be written as amount of solute that is milligram, upon amount of solution in liter. So parts per million by weight to volume or mass to volume, same thing, is we can write as amount of mass of solute in gram. So milligram we have changed into gram, and amount of solution in ml we have changed liter into milliliter, and we have multiplied 10 to the power 6 with the uh, conversions of gram to milligram. So gram to milligram, again we uh, and we have converted liter to milliliter, and we have multiplied by 10 to the power 6. Let us see one example to get a clear concept. Calculate the parts per million by mass to volume for 2-liter solution in which 2 multiplied by 10 to the power minus 6 kg sulfur is dissolved. So here 2-liter solution is equal to 2 into 10 to the power 3 ml, or we can write 2000 ml. Mass of the sulfur, which is solute, is given as 2 into 10 to the power minus 6 kg, or we can write as 2 into 10 to the minus 3 gram. Therefore, putting into everything into formula, parts per million by mass to volume, it is mass to volume, is equal to amount of solute in gram upon volume of solution multiplied by 10 to the power 6. So putting these values, mass of sulfur and mass of the solution, etc., we, after calculating, we got 1 as an answer. Therefore, we can write mass parts per million by mass to volume for solution will be 1 microgram per ml. Now, solubility. Solubility of a substance is its maximum amount that can be dissolved in a specified amount of solvent. It depends upon the value of the solutes, and it depends upon the nature of the solute and solvent, as well as temperature and pressure. So if we first experiment which we were doing for salt and water, let us increase the amount of salt which we were taken in our first experiment. So there will be a limit. After that, we can't dissolve the salt into water. So salt will not get dissolved into water after that proportion. So that is called solubility. That limit is called solubility for salt and water. So let us again see the definition. Solubility of a substance is the maximum amount. So it is the maximum amount which can be dissolved in a specified amount of solvent. So here we have taken 1 glass of water. So 1 glass of water that is fixed, there is a maximum amount, there is a limit for the salt to be getting dissolved. Again, if we increase the volume of water, then again the limit will be more, and we can dissolve more salt, but that is also in a limited way. That will also exhaust after some time. Salt will not get dissolved into the water. So that limit is called solubility. It depends upon the nature of the solute, nature of the solvent, and temperature and pressure. So if we increase the temperatures, for example, 1 teaspoon is dissolving in 1 glass of water. It is fine, say 100 ml of water. Now, if we try to dissolve 2 teaspoons, that is 20 or 30 milligram of 30 gram of salt into that much portion of water, it is not getting dissolved. But if we increase the temperature, if we start heating it, the solution, then at that position the salt will get dissolved into the water. So it depends upon the nature of solute, nature of solvent, and temperature and pressure also. So uh, now let us will see in details the solubility of solid in a liquid. So solubility of a solid in a liquid. It is observed that polar solute dissolve in polar solvent and non-polar solute dissolve in non-polar solvent. We have just few minutes back we have seen this. Example, sodium chloride dissolves readily in water while naphthalene and anthracene dissolve readily in benzene. In general, a solute dissolves in solvent if intermolecular attractions are similar in two. So it depends upon the intermolecular attractions. If they are similar, then that solute will dissolve in that solvent. Next is solubility of gas in a liquid. Many gases dissolve in water. For example, oxygen dissolves only to a small extent in water and plays a vital role for sustaining the aquatic lives. Solubility of gas in liquid depends upon following factors. So, first is effect of pressure, then effect of temperature. First we will study effect of pressure. The solubility of gas increases with pressure. The quantitative relations between pressure and solubility of gas in a solvent was given by Henry, known as Henry's law. Henry's law. The partial pressure of the gas in vapor phase is proportional to the molecular fraction of the gas X in the solution. So P is equal to KHX. Here KH is the Henry's constant. So basically, according to the law, P is directly proportional to the molecular fraction X. So we have removed the proportionality, and instead of this these two things came, is equal to and a proportionality constant. That proportionality constant is Kh, and Kh is known as Henry's law constant. So mathematically the equation is this. Different gases have different Kh value at the same temperature. This suggests that Kh is a function of nature of the gas. It is obvious from the equation that higher the value of Kh at a given pressure, the lower is the solubility. The lower is the solubility of the gas in the liquid. So it is given by this relation that higher is the value of Kh. So the relation, if we want to express, is that higher the value of Kh at a given pressure, so pressure is constant, lower the solubility. So lower the solubility of the gas in the liquid. So now we'll study about effect of temperature. KH value of gases increases when with the increase in temperature, indicating that solubility of the gas increases with decrease in temperature. So KH value increases with the increase in temperature. That means solubility of the gas increases with decrease in temperature. Now, application of Henry's law. First, to increase the solubility of carbon dioxide in soft drinks and soda water, the bottle is cooled under high pressure. First application is this. So whenever you open a bottle of cold drinks, you get uh, the gas try to come out with high pressure. So second application, at higher altitude, the partial pressure of oxygen is less than at the ground level. This leads to low concentration of oxygen in blood and tissues of people living at higher altitudes. Low blood oxygen causes symptoms of anoxia. Third application, to avoid bends in scuba divers, air is diluted with helium. Limitation of Henry's law. The law is applicable to the gaseous solute which first shows only ideal behavior at high temperature and low pressure. So it is important that it should show ideal behavior at high temperature and low pressure. It is applicable. So first point is that this is the limitation. Second point, does not undergo association or dissociation. Association or dissociation, it does not go when the solute is dissolved in solvent. Third limitation, does not form any product by the chemical reaction when gaseous solute is dissolved in liquid. So it does not form any product by chemical reaction when gaseous solute is dissolved in liquid solution. So let us solve numericals to get the concept. So calculate the solubility of CO2 in water in terms of mole fraction if partial pressure of CO2 is 2 multiplied by 10 to the power minus 8 bar at 298 K temperature and KH value for CO2 is 6.02 into 10 to the power minus 4 bar. So according to Henry's law, pressure of partial pressure of CO2 is equal to Kh multiplied by mole fraction. So X CO2. So X CO2 is equal to P CO2 upon Kh, which is equal to 2. Just put the values given in the question. So P CO2 is given as 2 into 10 to the power minus 8 upon K's value is given as 6.02 multiplied by 10 to the power minus 4 bar. So upon solving, we get 3.322 multiplied by 10 to the power minus 5. The solubility of carbon dioxide in water is in terms of mole fraction will be given as 3.322 multiplied by 10 to the power minus 5. Let us see one more example. Henry's law constant of CO2 in water at 298 K is 5 upon 3 K bar. If pressure of CO2 is zero point zero 0.01 bar, find the mole fraction. So according to Henry's law, P is equal to Kh into X, which implies that PCO2 is equal to Kh dot or multiply XCO2. Putting the given values, so zero point zero 0.01 is the value of PCO2, 5 upon 3 multiplied by 1000 is the value of KH, and we have to find XCO2. So it can be found by calculation, by the calculation. So KXCO2, the mole fraction of CO2, is given as 6 into 10 to the power minus 6. Let us see one more solved example. How many millimoles of CO2 gas will dissolve with CO2 gas when CO2 gas is passed in 900 ml water at 298 K temperature? The value of Kh is 6.02 multiplied by 10 to the minus 4 bar, and partial pressure of CO2 gas is 2 into 10 to the minus 8 bar. So mole fraction of CO2 is PCO2 upon Kh. This came from Henry's law. So putting the value of PCO2 and Kh, we get 2 into 10 to the power minus 8 upon 6.02 multiplied by 10 to the power minus 4, which gives us 3 into 3 to 10 to the power minus 5. Now density of water is 1 gram per ml, hence the mass of 900 ml water can be taken as 900 gram. So mole of H2O is equal to W by M, which is 900 by 18, that is 50 mole. Suppose the mole of carbon dioxide in N is N, then the total moles will be N plus 50, which can be written as 50 approximately. So mole fraction of CO2 is mole of CO2 upon total moles. So we can write mole fraction of CO2 is, we have find out before, which is 3.322 multiplied by 10 to the power minus 5. Moles of carbon dioxide is equal to N, and total mole is equal to 50. Therefore N is equal to, by calculating, we can find the N value as 1.661 multiplied by 10 to the power minus 3 mole. Again, it can be written as 1.661 multiplied by 10 to the power minus 3 multiplied by 10 to the power 3 millimole, that is 1.661 millimoles. Therefore CO2 dissolved in 900 ml water will be 1.661 millimoles. And this is the end of today's session. Please subscribe, like and share our YouTube channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you very much for watching our videos and supporting us.